Alright guys, welcome back to my channel, and in today's video we are going to be working on how to create a voting smart contract. Right. Alright, so the voting smart contract, I actually received this challenge on LinkedIn. I checked through the developer challenge, and it's more like a voting app. So and it's a Solidity challenge, so I decided to make a video and show you guys it's done. So this is the requirements for the challenge. Says ensure that all the state variables are private. So create a smart contract for the voting system, which is what we are trying to do. Then we have to implement a function for the contract owner to register new voter. We're also going to do this. Allow only the contract owner to add this, of course, to add new voters. So the function develop functions for register voters to cast their votes. Of course, we're going to do that, of course. Um, before we proceed, let me just check if my record is actually going well. Alright. Alright, so we are going to be writing the smart contracts, and I hope this you're going to learn from this and more about Solidity, how to manipulate and all of that. So we are going to write our contract, initialize our license, declare our version. So I'm just going to say voting. Alright, let's see the voting app, and right there we are going to first thing first is let's create our function, a register function. Which our function is going to take in just the name, string the name. Alright, we're going to make this public, and we're going to leave it. Then sorry, string, we're going to use call data other than memory. Alright, you know, and we are going to create struct right there. Struct called voters info. Alright, then we are going to give it an address. We will pass the address of the voter, and we are going to like pass the name to be in just string of voter. Oh, sorry, string the name of voter name. Let's just write name like that. I'm going to write in 256 or the votes count or voters count. I'm going to write a bool of is voted. Alright, make sure I written down first. Okay, so we've written our struct, and then before we proceed, we also need to write a function to check if the user is registered. So I'm going to write the function check if user is registered. Right there, it's going to take address, going to take in user, and it's going to be public. Alright, like that. And we are also, what we are going to do, we're also going to return like that. We are going to return a bool, and here we are going to return okay, before that we need to create a mapping of for the struct for us to be passing cool stuff inside that struct. We need to map the address to this voter's info struct. So how we declare mapping is mapping. Alright, create the mapping, then map the address because address is not like the identifier, which is what you're trying to do. Address is like the identifier. At the beginning you want the number to be the identifier, you're going to use in 256. So mapping, then the voters info, and we are going to make this public for everyone to see. Since the challenge didn't say we should make our mapping private, so public, and we are going to give it voters. So I'm going to give it voters info, small letter. Alright, so kind of different. So what we need to do is we are going to return bytes. Alright, we're going to return bytes. Then we are going to return. We are going to say voters info of what we are passing in of the user. Of course, we are going to call the name. Then we are going to get the length. It's greater than 0 right there. Okay, so is the spelling of my name is correct. Yeah, it's correct. So we are going to come here. We are going to check if a user is registered. We are going to call this function. Then we are going to pass in the name. We are not going to pass in address. My bad. We are going to pass in string inside our, because this is more like a string. We are going to pass the name. Then we are going to require that check if user of this name is mm, oh sorry, hold on. This has to be address. This has to be address. So what we need to do is we are going to require that the check if user is registered of the person calling it. Well, the message to sender, alright, is actually equal to false. Um, equals false. Um, I'm going to say user already exists like that. So we want to make sure that if you want to call this register function again, you want to make sure that you are not a user or you are not already a user. So if you're already a user, you won't be able to register again. So if you've done that, we are now going to require that the name, the name um, is actually a valid name. So how we do that is we are going to say require that the bytes of this name is greater than dot the length dot the length greater than 0. Then we're going to say a valid name right there. So and after we check for if you already use a valid user account, and if check for your name, if your name is actually correct, and what we now need to do now is for us to like add you into the voters info. So how we do that is we are now going to say voters info of person calling it, right? Let me see the sender dot the name dot the name uh sorry equal to name, right? Also passing the name. So, uh, implicitly convertible just with the text string. Like that. Okay. Okay. So what am I getting wrong? What am I getting of course, this should work, and I have no idea how it's going on. So name is equals to the name. What is going on here? Uh, I think give me a sec. So let's write an event. Right? Let's create our event. Let's call it registered event. We are going to write need the address indexed footer, and we need a string indexed the name. We have to meet our events. We need registered events. We need to pass in the MSC sender and the name. So it says text string call data is not implicitly convertible to type struct. Okay, I'm not calling the name. That's my error. I'm supposed to call the name. My bad. I'm supposed to call the particular function, like particular struct I want the stuff to go into. So I need to be like voters info dot the name is will be equal to the name going to the name here. So that's the error. Um. Okay. So that is done. Again, let me check if my recording is working. Alright. Cool. So we are done with the registration. Oh, sorry, we are not done. We are not done. So we are going to push. We are going to create an array of all voters, all voters. Sorry, I'm going to create the address public all voters. So we are now going to push this particular user into the array. So what we need to do is um, okay, let's say um I'm going to say all voters, right? All voters dot push. And I'm just going to push the um, let's say calling it like that. But I actually want to do something very cool stuff. So I'm going to create another struct. Alright. I'm going to say call it all voters info. Then I'm just going to pass in these two guys right there inside the struct. Alright. So what I'm going to do? Okay, we are told that all state variable must be private. I have to make this private too. I'm going to make this on top of this. All state variable must be private in that. So then I'm going to create a mapping. Sorry, an array. I'm not going to use a mapping here. So I'm going to say all voters info. Sorry, all voters. I'm going to use this all voters info. Then I'm going to for now let's make it public to see what we are doing. We are going to make it private later. Then we are going to call it it's all voters like that. Okay, so what we are not going to do is we are not going to say all voters info. All right, all voters dot I'm going to say all voters info right there. I'm going to call it all voters info dot push is unfound. No. That is not going to work. Okay. Let me say all voters info dot push. In fact, let's use all voters dot push. Then we're going to call all voters info inside. Then we're going to pass in the let me see the sender. Okay. I'm going to pass in this guy. I feel like let's just do the normal way first. We are going to connect to this guy. Let's start that. We're just going to pass in this um all voters inside it right there. So we're done with the registration function. Then what we need to do is we are going to create the what else? Function for the contract to not register new voters. So we're going to I just need to copy all of this. Okay. And we're going to come here. I'm going to say register by admin. So we're going to create a modifier. and a constructor. We are going to write a state variable for the owner. We are going to say address private owner. Alright, and we are going to create a constructor. The constructor is going to always dependency. I'm going to say the owner. I'm going to set the owner to be the msd dot sender default initially. So we are now going to write our modifier. We're going to say modifier, and I'm going to give it only owner, only the owner. I'll call this function because now what they said we have to write a modifier. Then we are going to um, require that only the owner. I'll call this function only owner. Sorry, require that owner equals msg dot sender right there. Else we're going to throw an error. Not owner. Okay, then we are going to close the modifier like this. Sorry, I'm going to close the modifier like this. Alright. So then it's written our only owner, so we are going to pass the only owner function then, so that we make sure that only the owner can actually add a name to this. Only the owner can um, register a new member. So, and then of course, if the owner actually wants to add plenty of users at once, we should also be able to do that one. Though even though it's not like it's not written here, but we should be able to like do that one. Okay, so I'm going to copy this guy. Still the same principle though. I'm going to remove this. So we are going to, instead of writing, we're going to have a string address and address and the okay, we are not done with this particular function because the admin needs to pass the address of the user. So after getting the name, then we are now going to write address of voters right there, or voters. So then we are going to make sure that we want to require that the voters is not equals to address of 0. Else we're going to throw an error, valid address. So valid address is not compatible with okay. It's saying the voters is not bad. And that should play there. So we require that the voter address is not equal to 0. That means we are passing in a valid address. Then we are now going to pass the voters information. Then the voters info of voter. Then I'm going to code the address, so the voter right there. So in order for us not to avoid conflicts, naming conflicts, so let's give this voters, and we are going to call this voter. Then it's going to be equal to the voters we passed in there. Then we are now going to remove this message sender. I'm going to pass voters inside of it. Uh, just to be voters. Yeah. So that means when the admin adds a name, he will be able to add the voters info inside of this one. Then the name is going to be stored there, the address. You can also write this function in a separate way. You can, other than writing it one by one, we can write it in a single line, but let's just read it this way. But if we're having a lot of, let's say we have to write like 5 or 4 of this, we can't be writing it one by one. Yeah, because I just want to write it in a line, a single line. So, but whichever the case, this works too. So the register by admin, then um, um, this one I want to write is not like it's not written in the challenge right now. But admin might want to add a lot of user and a lot of addresses. So what we need to do is just going to like create a string, array of string, array of address, and we are going to what am I using? Zero. Data location was memory or core data. Definitely not the address error. What's going on? What's going on? What's going on? I'm sure it's not about this. I'm sure it's not about the address error. So we are going to remove this for now, and we are going to leave the requirements, and we are going to write one more requirement. Require. So we are going to require that. We're going to require that string. Sorry, the name dot. In fact, the byte of name of the length is actually equals to the voters dot length. Oh, sorry, we are not going to use bytes for this. Just we are going to use just the name. And so we are going to try and because we want to make sure that the length of the address is actually the same as the length of the name. So if we, for example, if we want to add a um 4 names, right? We also need to pass in 4 addresses, right? Unique 4 unique addresses. But that means this requirements function, this line, is making sure that the length of the address, that is 4 addresses, is also equal to 4 names. So that means if you write 3 names and 4 addresses, that is not correct. Or even if we have 4 names, 3 addresses, that is still not correct. So we have to have equally 4 names, 4 addresses, 3 names, 3 addresses. That's what this line is trying to check. So um incorrect length. Alright. So ideally, we are supposed to be throwing a modified error function, because requirements and this naming, it actually consumes gas and the byte size of your smart contracts. But for the sake of this video, we are just going to follow the requirements in ways of doing it. So I'm trying to use 3 and 2 equals to regulars. I'm still wondering what why I'm getting this um address of cookies. Okay, so okay, sorry, my bad. I need to pass memory to the address because it's more like a storage, like there. So is it like passing code data or memory? So and what we are going to do for this is we are going to write a for loop, a for loop, and we're going to write it this way. We're going to say for during 256, oh, sorry, in 256 is equal to I, then I which is less than um, the voters info, um, I which is less than the address, go to the length, goes up, yeah, it's less than the address to the length, then we're going to do I plus plus, I, I plus plus right there. What am I going to do? On the client fire, oh sorry, for unit I equals 0, for unit I because we have to specify the unit I because I is less than address dot length. So I think I'm going to write have a um, um this has to be address, alright, address, and this has to be the name suppose. So it needs to be the address dot the length. We need to make sure the address of the length is actually equals to this. Not found visible. Okay. The spelling wrong. So make sure that this guy is actually equal to this guy. Name, then the name, so the length, and address. Length is not visible after argument dependent lookup. That's something hard. So it's basically you have to create of course that's to be voters. So you still you have it has to be voters because you have to call the voters this guy right there. Go to the links, go to this. Alright, so then we need to make sure that the voters got the length. Okay, then we are now going to call back our requirements from this guy. So, but before that, what we need to do is we are going to specify now say address, and then we are going to require that the name of each name. Now we are getting each of the name. Grab the name, dot the length is actually greater than 0. We're going to go through an error. Valid name. Okay, so close. So let's say right. I'm going to get the name like that, and hopefully this will work. Alright, cool. So when we're dealing with string, we need to use byte because you can't say string. So if you get that, so require, then you have to require the also the address too. Then the, of course, I'm going to use this. So I'm going to say address each. You're taking each of the address now. Sorry. Okay. Address of I is not equal to address of 0. Fully this will work. This will work. Let's see. Okay. What do we have? Integer question is okay. Check. So require the address of I students as you channel. Okay, my bad. So what I need to do is to get the voter supposed to get the voters, right? And that should get it. Alright, cool. Okay, then we are now going to since we've checked for the name, then we've checked for the addresses, then we are going to push um, the address and the. I'm just going to push. Since we are pushing just the address, I'm just going to push the. Um, I'm just going to push the voters, right? So we're going to like the voters get that. Same thing for the name. I'm going to pass the name to like that. So I'm getting wrong. Declare identifier. Okay, okay. Uh, I'm going to create a state variable. I mean, memory. This is going to work again. This is going to work. Okay. Well, in some cases, if you need to write a function, some code out of your for loop. So what you will do is going to is that you create a local variable, you create a memory variable to make that work. Well, in this case, that works. All right, we are done with the registration by the admin, and the admin can add lots of more than one user, and the user can just add admin can just add one user, but admin can add more than one here. So what else do we need to add now? My bad. Allow only the contract owner to add new voters. Okay, fine. Okay, it says voters. We've done this. So create a modifier or only voter for or a function to check only registered voters can interact with the contract. Okay. This is why they want to vote. Alright. So we are going to create another modifier. Then we are going to call this only registered voters. Only registered voters. Then what we need to do is we're just going to grab this guy. In fact, We're going to create this requirement statement. We are going to pass it inside this. Then we are going to this. If I make this like this, it's still the same thing as making it without that because default initially is going to be true. True. Alright, so I'm going to do like this. So, and I'm going to say uh, account not found. Account not found. That means the user have not created an account. Alright, so right there. Um, so then I'm going to grab this. I'm going to create our vote function. Our vote function. So I'm going to function vote. Then you're not going to take in anything. Alright, so I'm going to make this public and only register owner can call that, and you're going to return double and just to make sure use our a better coin smart contract flow and check if it's okay and stuff. Then you see how what I'm going to do with this bull returns right there. So what we are going to do with this vote is that we are making sure that only the registered voters can call this function. Then we are going to create a state variable and we're going to call it unit 256 private um, vote count vote count. Alright, so I'm going to grab that and we already make sure that um, the person calling it is actually valid register member. So what else do you think we can do to this? Mm, we're going to create an event as well, an event, and this one be voted, and this one be address in text vote voter, and then we're going to create this. We're going to come here. Then since we already make sure that only the voter can make this, then we are going to call this vote count. Um, I'm going to call the vote count right there. So in Solidity, there are a couple of ways you can add more to your state variable, like add plus one to a particular variable. You can do it this way, and you can do it that plus one. But we don't want to use this plus one because we don't want to use this particular way of calling it. And before that, we also want to make sure that the required state of we also want to require that we're also going to require that um, this user haven't voted before. This particular user that is trying to call it haven't voted. This is voted there, so we are going to go back here. Then we are going to require that um, um, voters info. Voters info of the person calling it dot is voted. Remember, yeah, is voted. It's actually is equals to false because initially it has to be false initially. Alright. If this is true, I'm going to return an error saying already voted right there. Then I'm going to do that. Then if that one is not true, okay, this is voters info. And if that one is not true, we are going to pass in. Then we are going to count count the voters. So we are going to say vote count. We are going to add it, plus it up. Then we we are going to set after the user has voted. Then we are going to set this. the voters info, the message you're saying that is voted will not be equals to true because the user has already voted. Then and then like that we sorry, this has to be equals, not equals. Then like that we are going to emit our voted voted and this is the MST to sender right there. All right. Cool. Then our functions are getting ready. Our voting smart contract is getting ready. So what we need to do now is we need to return all voters. Before that, we also want to make we want to go back to this register by May. Okay, we've done that. Done that. All right, and then it's voted. Then what else do we have here? Okay, we are also going to return true. All right, so the 21 we have to return this our bool right there. So we have to create a function to retrieve the current votes count. So we are going to write a function right there. We're going to say function. Since it's private, all our state variables are private, so we need to write a function that gets it out. Gets current votes count. I'm going to make this public. I'm going to make it view. We're going to return June 256. Then there we are going to return our our votes count right there. I'm going to return our votes count, and then that should be able to get us our count. Then we also want to return all voters. All right, so I want to make it very cool stuff before, but it's not written here. Then we're going to return all voters. Then we're going to come here. Then we're going to say function gets all voters info. Of course, this has to be public too. Public view returns. And it's going to return this all voters array memory right there. It's going to return all voters array memory, and it's going to return okay, since it's no more it's not a struct, so so it's just going to return all voters right there. Right. Name has to refer to a struct in or contract. Okay. So that's where the problem is coming from. Then since it's just an address, alright, let's return the address, array of address. Then I'm going to specify memory for that memory. So if you're just returning an address, you are not returning a struct. Because initially I wanted to make this a struct, if you guys remember, but I want to pack everything to give the detailed information about them. But this is just going to return just the address of the user, and we're going to return all voters right there. That should be. I'm having errors. Okay, alright, then we also want to return the voters information, so that when you pass in the address of the voter, the address of the voter, you're going to return the information for them, like their name, their their vote counts if the person has voted. In fact, this is what we are supposed to do here. Uh, okay. So I don't think they say all voters info capital letter. All voters info will be let's say all voters. Let's make this later. Actually, we are done with the smart contract. We just want to add more cool stuff inside of our smart contracts. That is undefined already started. Okay, let's return that to that. Okay, all voters info, get all voters. Then we are now going to like call this inside of our function. Then we are going to say get all voters dot push into the um into all voters info right there. I hope you guys are following along. It's quite simple though. Then we are going to add the name and the address and the name inside of it. So we are going to say msg.sender, comma the name, and this is going to return a lot of information for us about the particular voters. So that means we can do away with this. This works too if you just want to return just the voter. Just the address. If you just want to get the address, you map through the address and return it. That works. But since we are going to get the name and address of this particular user, that works fine. So we are going to do the same thing for this admin. And we're going to return this and we're going to return the name too right there. And we're going to register by admin to then we're going to come here, we're going to pass in the voter, we're going to come here, we're going to use the voter, and call the voters, passing the name right there, the voters index. So, what we now need to do is just, we are going to return all voters info right there. Then we are going to return get all voters. I'm going to return gets right. I'm going to return the get all voters. If I do that correctly, yeah, get all voters. Let's just copy and paste it. So get all voters. Cool. That is it for our voting smart contract. So what we need to do is we are going to like test it out and see if everything works. So again, let me check if my recording is working. Cool, that works because sometimes I'll make videos and it won't record. Sucks. So then we are going to deploy the smart contract. So before we finish our deployment, and before we deploy the smart contract, I need to go to my deploy scripts right there and change the name because I gave it voting the other time. So voting DAP, and I'm going to come to this place and I'm going to run it. I'm deploying it on core DAO chain. Alright. So it's getting compiled. We are seeing this yellow stuff. This one is actually cool. It's just a warning. The contract is going to work. So this is our voting address right there. So I'm just going to copy that. Um, Then we are going to head over to remix. I'm going to head over to remix like that. And yeah, because of course we won't be writing the testing. I won't be doing that now because it needs to take more time. So I'm going to go to remix and have a quick overview about what we're doing. I've done this before. I'm just going to go back to um, just going to go back to this guy, to our vote does so. Alright, and I'm going to update. I have to update the because I've written it before and I made some changes while doing it here. So I'll just copy this and paste right there. Um, I'm going to go to the deploy script right there. And I'm going to copy this. And I'm just going to deploy it on blockchain because so the time has to pop up. Because of course the name and the addresses they are the same. We need to connect. I've actually deployed it before. Since I've deployed it before, I'm just going to like interact with it after the connection, of course. So 115 getting connected. Okay, cool. So I'm having zero. So uh, that is not okay. It's probably missing. No, that's not okay. So I've deployed the. You're just going to get the address that we deployed right there. You're going to deploy it and interact with it at address. Let's call the without us registering, right? Let's call the vote function. That shouldn't work. Alright, so it says account not found. That means you haven't created an account. So if you extend this transaction, it's going to fail. Okay. So we need to register. Alright, so register and say tutorial. Alright, so hit the registration button. Um, so um, alright, so successfully registered. And if you click on vote, right? Let's look at the get of voters info. We haven't because get of voters info since I've registered, so it's going to return my name, which is tutorial, as you can see here, and my address, which is this address right here. All right, so get current votes. Our current vote will be zero, but if I hit this vote right there, the current vote should be one. That means I've voted. Alright, so it's confirm and it's confirm for the transaction and look at the current votes. Current votes is now one. Alright, so if you get all voters, this will be in form of an index, right? Array. So we're going to pass in it's passing in. So let's see. Alright, so this is my name. If this is it, alright. This is me that I just registered. So if you're passing one, like the second person, that's going to return error. You can see it's showing error here because no, another person haven't registered, of course. So then I'm going to change the account address here. All right. So I want to add a name as of course as an admin. Okay, we all know that it's only the admin that can add the name, right? So I'm just going to copy down my address right there. Sorry, my name. I'm going to say John Doe. Alright, so I'm going to pass the address and I'm going to run this transaction and it should throw an error. Hopefully, in fact, it should. And not the owner, because only the owner can call this function, right? Cool. So I'm going to go back to um, my. So let's test this one to this a lot of addresses, array of addresses and names. The name we are going to specify the name by this. We are going to write John. Then it's going to be in the string. Let's write John. Uh, John. Um, do if I come here by passing just one address, this should return an error. You can see it's going to return an error by default. And I do okay. So if I run the transaction again, it's going to return an error. So that error is not the error I'm looking for. This is the error that this is not correct. And okay, still an error. So the string, they're not the same. So I will need to make command there. Oh my bad. This guy is not closed and it should be closed. Alright, cool. That should return an error because the address here is not the same as the name. I'm passing in one address and I'm passing in two names. You can see. Okay, it's still returning not the owner. We are going to try this exact way with the owner now and see what address is going to what is going to return. And we're going to run it again and it's still saying not the owner. Let's get the owner. Okay, we made the owner to be private and we couldn't return the owner. Okay, no, let's just step through. Let's step through. Now the owner, let's see what the code says here. Register by admin, correct links, and only owner can call the function. Of course, myself, how about we call this guy? Because I could never use this first address to run that. It's just saying not the owner. That means there's an error somewhere. That is this not the owner. This guy. Probably I'm going to run this function again and see what is going on. Okay, so we are just going to check if user already exists right there. We're going to pass in the address. Ideally, we are supposed to make this private though. Oh, yeah. This should return true because the user already exists. It's confirm. It's confirm and should return the value for right there. Permission is pending. Okay, oh, because you're not returning anything here though. Because we did return the byte. You should return something for us. Okay, we didn't like specify to return anything. This is not really necessary though. Again, let's check the let's make the owner to be public. Alright, let's make owner to be public. Let's make the owner variable to be public. Solid okay, okay. So we're just going to use the version just to make things quick. We're still going to deploy later on. Just to make things quick, we're going to use this like the virtual machine. Um, oh, so here in my network. Okay. Still thinking as well to do okay. Say that I want this. Let's review the site. Okay, let me check if the record is going well. Yeah, it should be well. Something on my network. Come on. Okay, let's check. Let's return this guy to the public. Yeah. So okay, so we go to the contract. We go to the vote. Where's the vote? So, vote right there. It gets compiled automatically. Let's copy this guy again. I think it's one like my network. I'm not sure. Just to test the owner issues and bring it back. We are done actually. So just want to test it back again. So credit, to the credit directly, just to avoid issues. Yeah. The person compiled, use the credit again, and we're going to we've tested the registration file. We are using this address. I want to use this address to add the name. I want to say John, then pass this address, and we transact. I'm still saying not the owner. So the issue here is that um, supposed to say the owner is the sender. Okay, so I even have said mg dot sender is equals to the owner. Fact. Supposed to the owner. I should take it with the sender. So if we deploy, we are going to add this guy again. Say John, then passing this guy. Transact. Still returning all the owner. Um, the owner. What's this owner? Okay, okay. Let's get the owner. Okay, the owner is returning not a valid address. Okay, of course, that won't be the owner, definitely. Equals to the owner. Hmm. Okay. Now we have a valid owner, then red John and the address transacts. Yeah, that works. The reason why it's throwing error is because the owner was returning an invalid address, which is definitely not equals to this address. So then, and the issue here is I said owner equals MSC sender, which shouldn't be. It should be owner is just equal to the person sending it. So that way it's going to get the address. Alright. So let's head back to our um, our adding a lot of users right there. So we're going to say John, then we're going to say do, then we're going to come here, we are going to pass in just um, one address, the transact, and looking at the error, it said incorrect length. Alright, that's correct. So what we need to do is, because this, we look at this, because this address have actually been registered, it should throw an error. Alright, so I'm going to write comma. I'm going to write this. Hopefully it should throw an error. That shouldn't work. Okay. Okay, the reason why it works was because I didn't specify the address. I only used the person sending it, and the person sending it is already not an owner. So what we need to do is just to we have to rectify that as well. That's part of testing. You know. So transact. If you check the all the current current voter, current get all voters. Now you can see Do is part of them, John is part of them, and another John right there. So that means this is working. But what we need to do is just we need to make sure that the address that we are passing in is actually um, uh, uh, already is already haven't voted. I mean, the address is no haven't created an account in our smart contract. For example, if you look at this check, if user is registered, that means you want to make sure that the person, the addresses, each the addresses the admin is adding inside haven't um, created an account already. So if the user have created an account, you should try an error. So this should work. Okay, I think that is working. Taking of else. So checking user is taking in the yeah that's okay. It should take in this guy. Um, it should take in instead of taking in address, it should take in the voters right there. So then it should try an error because I've actually used this account to create it. So now I should try an error. So let's try it again. So we're going to come here. We're going to use the same address we used. This text here. We're going to create an account. Register an account. Sorry. I'm going to register by admin. I'm going to write John. I'm going to write the name, and I'm going to transact. What do we have? Oh, sorry. That address is not correct. So, right there. So account has been registered. So if you come here and if we see John do we come here and we write the address at comma the address and close the array and we hit transact, that should throw an error and you say user already exists. Alright, cool. That's correct. So that means if the admin wants to add a new user in address, so this line is checking that the address the admin wants to add is not is actually unregistered account, like unregistered address. So if the person has already been registered, it should throw an error. So that is what this line does. And of course, if you are trying to register here again, you should try an error that okay, register by admin. And yes, I'm using images of sender here. I'm supposed to use voters here. That's part of you testing your smart contracts. Very, 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 very good. Alright, so if I test this again, if I deploy this again, test it, this should throw that error too. Alright guys, that is it for this video. Okay. Okay, let's just use a valid account then. Let's use a valid account for these two guys. I'm going to write this for the first one. Then for the second one, I'm going to use this for the second one and go back to the main account. I'm going to use this for the second one. Yeah, I'm going to change the name. I'm going to change it to Kelvin and Josh. Okay. So I'm going to hit transact. That works. And if I check my get all voters right there, you can see we have Josh right there, we have Kelvin right there, different addresses, we have John, and we have I think we should have the two. We have John. I think I didn't specify those, so that's the next thing. So now you can get the current vote count, which is still 0. So if you vote, it's going to get it's going to read in this get current vote. We've tested that before. Then if I get this, we want to get the information of this guy. All right. So if you go back here, if you paste the address there, then you get the information. You can get the voter's address is this, then the uh, get voters info. Okay, we shouldn't. Um, okay, okay. Get voters info. The voters count is 0. It's voted is false. Um, okay, the person haven't. Of course, you should return the name for us. The name because this guy should return the name for us. So let's open that. That means it's not seeing. We are not getting the name. That's all voters info. Okay, get all voters right there. This works too. If you pass in the index, so you should return everything for us. And say voter, the name is John. Alright. Pass in this 4, the name is Josh. And you pass in 5, do you have 5? No, we don't have 5. Pass in 3, the name is Kelvin, which is this address. This is what it's supposed to return here. It's supposed to return Kelvin for us. Volume white, return Kelvin. So whichever way you can do it this way, you can. But while returning this in the front end, you don't want to be passing this addresses like you don't want to pass in 0, 1, 2, 3, blah 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 blah. You always want to just get the address and just return the information. So for the sake of that, we need to like return the voters information. So that is what we should try to do now. Let's see. Since we're able to get the voters there. Okay. Get all voters. Okay, you know what? Rather than saying this is also the function, right? But so other than saying get voters, we just pass in the address. Okay, let's pass in address and we say voter right there. Then I'm going to pass in get info. Sorry, voter. Oh, that will return an error. True. We are now going to return home memory. What we are going to return is I'm going to return a string. Uh, string. String. What's the error here? It says turn type is not easily convertible to this. Okay. It says return argument type strokes within the storage. Okay, come on. Actually, this should work, or is the mapping? Okay, okay, we need to create a mapping then. Alright, create a mapping. Create a mapping of address. just need to return this. We should make it public. You can make it private too. But this is voters info. This is when it's return error. Public. Make it private. This is necessary. Voters. Then I'm going to return voters of the address. Return So it says return argument type struct of voters is not implicitly convertible to expected type. Type of first return. And okay. Did I get this correctly? This should return this way. We should return this and ideally we should be able to return this without even without the mapping. Let's return the get info get good. Can't believe I just did this. You've actually gotten all voters information, but gotten all the voters information here. Can't believe I skipped that. So get all voters information, return everything here. Alright. That's it for this video, guys. If you like the video, please subscribe and subscribe to my channel. It's another video. I'll see you.